Welcome to this video. Today we talk about units and measurements, basics of physics, units and measurements. Now, what do we study in physics? We study about matter, we study about its motion, we study about the space, the time, and we study about the energy, the force, the mass, the weight, the pressure, and its impact on the volume or size or ability of that object to remain in the particular state. We also study physics in the form of various disciplines like or various branches like mechanics, heat, light, optics, etc. So all the observations and all the experiments that we do in physics on the nature and the phenomena of the nature. What is nature? The matter, the elements and things like that. What is natural phenomena? The heat, the light, etc. These observations and these experiments when we study physics lead to certain facts. And what are these facts? These facts are the things that can be explained on basis of certain laws. For example, the Pascal's law or the Archimedes principle, etc. So the study of matter and its motion, as well as the space and time using concepts of energy, force, mass, charge, etc. that lead to certain facts and which can be explained on a basis of certain laws and falls into certain disciplines like mechanics or thermodynamics or heat or light or optics, etc., acoustics, etc., is called physics. The comparison of any physical quantity with its standard unit is called a measurement. When you compare something with a standard unit, it's called a measurement. Then what is a standard unit? Standard unit is a measurement of any physical quantity that involves comparison with a widely accepted, easily reproducible reference unit. So measurement of any physical quantity that involves comparison with a certain basic, widely accepted, easily reproducible reference standard is called a unit. Measurement in comparison with a widely accepted reference is called a unit. Now there are two types of units. One is fundamental units, that is units which can neither be derived from one another nor they can be further resolved into simpler units. Fundamental means that cannot be further resolved into fundamental units. What are derived units? Derived units are those measurements of the physical quantities which can be obtained from the fundamental unit. Fundamental unit cannot be derived from anything else, but derived unit can be derived from the fundamental units. For example, length is a fundamental unit while velocity is a derived unit. Why velocity is a derived unit? It's a rate of change of speed. What is speed? Speed is rate of change of distance per unit time. So because this is velocity is a derived unit and fundamental unit is length or distance. Now there are various systems with which we measure the units. Now physics means the study of matter and motion. Measurement is we can any physical quantity we can measure when this is compared, when that is in comparison with a standard, it is called a unit. The units are fundamental or derived. Now how do we measure? What is the system of measurement of these units? One is called a CGS system, that is centimeter gram second system. Now this is a little bit older system and this we use for length is centimeter, mass is in gram and time is in seconds. Then we had a British system which is a FPS system where foot was used instead of centimeter for the length, pound was used instead of grams and again second was used for time. Then it evolved into MKS system, that is meter, kilogram and second. Instead of centimeter it was meter, instead of gram it was kilogram and then second remained second. Thereafter all the scientists together formulated something called international system international. It's a French system where it is an extended version of the MKS, meter kilosecond system. Now in international system we have 7 base units and 2 supplementary units. We have 7 base units and 2 supplementary units. Now what are those? Length. Length is measured in meter. The symbol is m. What is it? The path traveled by light in vacuum during a time interval of 1 by 299,792,458 part of a second. 299,792,458 part of a second. Now we will study later what is the significance of this 299,792,458. We have something called a light year. Now the length of meter is how much? Meter is the path traveled by light in vacuum during 1 by 299, 792, 458 part of a second. Or we can say in a second light will travel 299, 792, 458 meters. Mass is kilogram, kg. What is mass? Mass is, there is an international prototype. Prototype means a model, a sample kept in a museum in France. The museum is called International Bureau of Weights and Measures. International Bureau of Weights and Measures. It was formalized in 1889 and that is made up of platinum iridium alloy. It is made up of platinum iridium alloy. It is in cylindrical in shape and mass is that particular object. Mass of that particular object is considered as a standard kilogram. Now we know when we measure mass as a kilogram, this is different from weight. Weight is the force of gravity acting on a mass. This weight, the physical in physics, weight is different. In because of the gravity, weight in Earth will be different from the weight in Mars. Mass is the kilogram. Mass will remain same. The mass is the number of molecules of that matter. That will remain same whether in Earth or in Mars or somewhere else. So mass is equivalent of the 1 kilogram mass or the standard is equivalent of mass of the international prototype of platinum iridium alloy cylinder kept at International Bureau of Weights and Measures at France. This was formalized in 1889. Then comes second. What is second? Is a duration of 9,192,631,770. 9 billion. 9,192,631,770 periods of radiation corresponding to the transition period between two hyperfine, hyper means high, fine means small, hyperfine levels of ground state of cesium-133 atom. So we have an atomic clock and in 1967 this was formalized that second means the time duration of 9,192,631,770 periods of radiation between two hyperfine levels of ground state of cesium-133 atom. Now when we have a ground state, we have a normal and abnormal state. That is why we say specifically. So length means light traveling in vacuum. Time second means the radiations during ground state. So these are all specific hypothetical situations in which we have arrived at the standard. What is electric current? Electric current is ampere. What is ampere? It's a constant current which between two straight parallel conductors of infinite length, two straight parallel conductors of infinite length of negligible circular cross section, that means very thin, very fine wire placed 1 meter apart in vacuum will produce a force. Why? When electricity goes on a wire, it will create a magnetism. When magnet is there, and there is a coil, it will create electricity. These are called electromagnetic effects of related concepts. Now, when this wire is kept in a vacuum, not a coil, a straight wire, they are kept in vacuum with 1 meter apart and they are of infinite length and they are straight and they are of negligible circular cross section. Now, they will produce a force and the force between these two conductors is 2 into 10 power minus 7 Newton per meter. 2 into 10 power minus 7 Newton per meter. This was formalized in 1948 as the electric current or ampere. Now in our home we have an ampere meter. It will tell how much electric current we consumed and then it gets converted to kilowatt hour based on how much energy that was generated and things like that. So ampere is 2 into 10 power minus 7 Newton per meter, which is the force produced when two wires of 1 meter apart, negligible cross section, straight and parallel, kept in a vacuum on which constant current is passed. What is thermodynamic temperature? Thermo is heat, dynamic is changing, temperature is the measure of heatness or coldness of an object. Thermodynamic temperature is measured in Kelvin K. What is Kelvin? It's a fraction of 1 by 273, 1 by 273, 1 upon 273 of the thermodynamic temperature of a triple point of water. This was formalized in 1967. What is triple point of water? Triple point is a value of the pressure and temperature at which water coexist in equilibrium in the three states. What is the three states? Solid, liquid and gas. So ice, water and vapor coexist in equilibrium at a specific pressure and temperature, that is called triple point. What is that? 273 K temperature or 0.46 centimeter of mercury, like 0.46 centimeter of mercury height, column height. Now this is the thermodynamic temperature. That is why this is 273 K, or the Kelvin is a fraction of 1 by 273. Now what is amount of a substance? Amount of a substance is measured in mole. It is written as MOL. The mole is the amount of substance that contains as many elementary entities, as many elements or as many atoms of that element as there are atoms in 0.012 kilogram of carbon 12. It is called carbon 12, that is why it is 0.012 kilogram. 0.012 kilogram of carbon 12 you will take, and then you will measure how many atoms on it. Now if there are X atoms, then mole is amount of substance of X atoms in a particular thing. That can be calcium, that can be potassium, that can be gold or silver, Ag, it can be anything. It is compared to equivalent of as many number of atoms as in 0.12 kilogram of carbon 12. This is the mole. It was formalized in 71. Then comes a luminous intensity. Luminosity is what? How much bright it is, how much light you get. Luminous intensity is measured in candela, CD. What is it? It is the direction, in the given direction of a source, whenever the light comes from the sun when the lights come, or from the torch when the light comes, from the given direction of the source, that emits monochromatic radiation. If it is monochromatic radiation only, you can properly measure candela. If it is multiple colors, then it will be a different measure. Monochromatic radiation frequency should be 514 to 10 power minus 2, 514 to 10 power minus hertz. So and this has a radiant intensity in that direction of 1 by 683 watt per steradian. 1 by 683 watt per steradian. Now what is a radian? What is a steradian? We will see subsequently. So 1 by 683 watt per steradian or 514 to 10 per 12 hertz is the luminous intensity or candela. So here we have seen 3, here we have 4. These are the 7 base units. Now we have 2 more supplementary units. Now what are the supplementary units? One is a plane angle radian. What is a plane angle radian? It is measured in rad. It's an angle subtended at the center by an arc of a circle having a length equal to radius of the circle. So you take a two-dimensional thing, you take a circle, they measure the radius of the circle. Now the angle subtended by an arc of the circle having the length equal to the radius of the circle. Now you know how to draw an arc on a circle where the straight line portion is equal to the radius of the circle. When you have such as arc, the angle subtended at the center by an arc of this circle is the d theta, which is the angle, and it is ds by r, where r is the radius. Now we have something called solid angle. The plane angle it is called radian. For solid angle it is called steradian. It is measured in SR. What is a measure? It is a solid angle subtended at the center of the sphere. It is not the angle subtended at the center by an arc. It is solid angle subtended at the center of a sphere by that surface of a sphere which is equal in area. There we had equal in radius. Here we have equal in area to the square of the radius of the sphere. Radius of the sphere is r, square of radius of sphere is r squared. So it is dA by r squared, where A is the area, dA by r squared. Now angle subtended by a closed curve inside is 2 pi rad, while the solid angle subtended by a closed surface at the inside point is 4 pi steradian. 2 pi rad and 4 pi steradian. Now when we measure, when we have this SI units, 7 plus 2 measures, when we measure any physical quantity, when we measure, the digits about the correction of which we are sure plus the last digit which is doubtful is called the significant figure. Now after the doubtful figure, then we have so many more figures of the measure which are not considered as significant. This is a significant measure. Now what are the minor measures commonly used? Length, we use minor small ones as a micrometer. 10 power minus 6 is micrometer. Nanometer, 10 power minus 9 is nanometer. When we measure atoms, we measure in nanometer, 10 power minus 9. Angstrom is 10 power minus 10. Angstrom is 10 power minus 10. We write A and put a degree symbol on the top of capital A. Mass, how do we measure? Metric ton is 10 power 3, higher side. 10 power 3 is metric. Micro is 10 power minus 6. Milli is 10 power minus 3. Metric is 10 power 3. Pound is 0.45 kilogram. 1 pound is 0.45 kilogram. Now we can write 0.45, 0.4537, 0.454. It is all approximations 0.4537. So up to 7 when we write, it is called a significant number. After 7 we may not be very sure. AMU is a unit for small measurements. It is 1.6 into 10 power minus 23 kilogram. How do we measure volume? We measure volume in liters. 1 liter is 10 power minus 3 meter cube. Meter cube. Volume is measured in meter cube. Force is 1 dyne equals to 10 power minus 5 Newton. Or 1 kgf is 9.81 Newton. Kgf is 9.81 Newton. Now when we have work and energy, we measure erg. Erg is 10 power minus 7 joules. While kgf per meter if we have, it will be 9.81 joules. Kgf is 9.81 Newton. Erg is 10 power minus 7 joules. So kgf per meter will become 9.81 joules. Kilowatt hour, kWh, kilowatt hour, which we have in our electrical meter at home, is 3.6 into 10 power 6 joules. That is energy, 3.6 into 10 power 6 joules. While EV is 1.6 into 10 power minus 19 joules, 10 power minus 19 joules. These are some of the common measures for length and force. Now for power, it's again kgf is meter per second, 9.81 watt. Watt is W is a watt. Horsepower is 746 watt. Pressure, how do we measure? 9.81 Newton per meter square. 9.81 Newton per meter square. Also, 1 mm of mercury. What is 1 mm of mercury? How we measure pressure? For example, when you have BP, when your blood pressure, as a hypertension, when you go to doctor for checking in a clinical um, measurement, what we have is 80 to 120 you will have systole, diastole. So like that, it is 1 mm of mercury is 133 Newton per meter squared. 1 kgf is 9.81 Newton per meter squared. Pascal is another measure of pressure. 1 Newton per meter squared is Pascal. 1 Newton per meter squared is a Pascal. Atmospheric pressure, we measure it as 76 centimeters of mercury. 76 centimeters of mercury, which is 10 power 5 Pascal. 10 power 5 Pascal is atmospheric temperature. Sorry, pressure. What is Fermi? Fermi is 10 power minus 15 meter. X-ray unit 10 power minus 13 meter. Astronomical unit 10 power 11. For a standard astronomical unit, we take the distance between the sun and the earth. And when we say mean distance, what do we do? The earth rotates around the sun on an elliptical path. So we have a apogee and perigee, the nearest position and the farthest position based on the ellipse. So the average we take is called the average distance, and that is 1.49 into 10 power 11 meters. Now we also measure sometimes in 10 power 9 or sometimes in 10 power 13. All those is because whether we measure in meters or centimeters or kilometers, based on that this will change. So in meter terms, 1.49 into 10 power 11 is the distance between sun and the earth. This is one astronomical unit. Astronomical unit AU. Then we have a light year. Light year is 9.46 into 10 power 15 meter. 9.46 into 10 power 14. So that is why when we were talking about length, we have this 1 by 299 part per second. So light hour is 9.46 into 10 power 15 meter. This is 10 power 11 meter. This is 10 power 15 meter. And what is parsec? Parsec is 3 into 10 power 16. That is 3.26 light year. 3.26 light year. 1 light year is 9.46. Parsec is 3 times 3.26 light year. So these are the common units. Now when we are measuring, we will have a significant figure and a non-significant figure. Significant figure is the number of digits up to which we are very sure of the value, of the magnitude of the measurement. A measurement is usually expressed as A into 10 power B. A into 10 power B. So that we know what we are talking about. Where 10 is the power to which B is raised. 10 is the power to which B is raised. In 2.738, the number of significant digits is 4. That is, we have total 4 digits, 1 before the decimal and 3 after the decimal. We have 4 significant digits. In 2093002, here we have 3 significant digits, here we have 4 significant digits. Where we have placed a decimal is not the concern, how many digits we are considering to give the exact value of whatever we have measured. This is the significant digits or significant figures. In 0.00807, here actually there are 5 digits to the right of the decimal, 1, 2, 3, 4, 5. But still, only 807 we consider as a significant number. We don't consider the 0 after the decimal which are preceding the actual digits. We don't consider the 0 which are preceding the actual digit, zeros after the decimal. In 12.3, meter can be written as 1230 centimeter. Why 100 centimeter is 1 meter? This can be written as again 100, 1230 millimeter it can be written, but they all has only 3 digits, because here also we have only 3, here also this is a 0, so only 3, because this is a 0, only 3, it is called 3 significant figures. So whenever there is a significant figure, we write the significant figure and the rest we write as a into b, 10 power b, so we write 10 power 2 here. 3.8 kilogram has 4 digits, though there are 2 zeros after. Because of this decimal, overall it is as considered as 4 digits, because the zeros are after the significant digit. Here zeros are before, so we consider as a 3 significant digit, but here we consider as a 4 significant figure. In this, when we add, suppose it is 423.5 and then 0.92 and 0.381, though the decimal is 1 decimal, 2 decimal, 3 decimal, because this is the closest decimal, we will express the answer as a single decimal. Least precise is this one. This is a least precise. So the answer after addition we will inform as only single digit. Now suppose we have 0.764, it will be rounded as 18.8. This 764 can be made as 8. Why? Because 5 is more than 7 is more than 5. And 18.74 means it will become only 7, because 4 is not more than 5, 4 will be rounded off to 0. So 74 will become 7, 76 will become 8. This is how we round off. Likewise 17845, 5 will become added to other, this 4 will become 5, 85 will become, it can become 9, it can go, it will become 1784. The 5 is, because it's exactly 5, it is 84. But had it been 6, if it is 875, it will become 88, because this 5 can be added. When it becomes 2 digit, 845 will become 84, 875 will become 88. Why? Because this 7 is on the more than 5, it will get added as a 8. So this can be adjusted like this depending upon where the 5 stands. Difference between the true value and the measured value is the absolute error. Whenever we measure, there will be an absolute error. So now there could be multiple absolute errors depending upon how many times we measure. So what is mean absolute error? Mean absolute error is the arithmetic mean of the magnitude of all the absolute errors. Arithmetic mean of the magnitude of all the arithmetic errors. Now, so relative error is mean absolute error by true value. Mean absolute error by true value. Mean absolute error is arithmetic mean of all the absolute errors. Absolute error is difference between true value and the measured value of a quantity. Now, what is accuracy? Why there is an error? Because you measured, you try to round off like this, and then you use one of these quantities or units of measurement, but still there could be a problem because of multiple reasons. Now, what is accuracy? Accuracy is how close is the measured value to the true value of the quantity. How close is the measured value to the true value is accuracy. What is precision? Precision is what is the resolution, what is the limit, what is the significant figure that you arrived at. What is the resolution of the quantity is measured by measuring instrument. Now each instrument will have a different limits of resolution. Each instrument will have a different units of limits of resolution. So precision is how precise the instrument can measure. Accuracy is how close is the measured value to the true quantity. Now what is least count? Least count is the least value that can be measured using an instrument. So Young's modulus will have a different least count, Verniers caliper will have a different least count. Least count is the least value that can be measured using an instrument. The minimum value on the calibrated scale divided by the total scale. That is how we measure. What is dimension? Dimension does not depend on the magnitude. 5 meter means 5 is the magnitude and meter is the unit. Dimension does not depend upon magnitude or units. Dimension is the power to which the fundamental base quantity are raised to represent the quantity. 10 power 3, 10 power 4 like that. Dimension is the power to which the fundamental base quantity is raised to represent the quantity. For example, force equals to mass into acceleration. What is mass? Mass is in kilogram, for example. Length is in meter, for example. Time is in seconds, for example. So force means mass into acceleration, but acceleration is length per time square. Length per time square. So it will be time power minus 2. So how do we write? We write mlt minus 2 time square. So why we are able to write like this? We are able to write like this because of the homogeneity principle. What is homogeneity principle? The dimension on left hand side and dimension on right hand side will be same. What is dimension? Dimension is the power to which the fundamental base quantity are raised to represent that quantity. Dimension does not depend on magnitude or units. Where is dimension used? Dimension is normally used to check the accuracy of whatever we have calculated in the equation. Dimension is used to convert from one system to another, CGS to MKS types. Now, what are some major dimension values? For example, power is measured as watt, is a SI unit. But how we write ml square t power minus 3 second cube per second cube. So power. Or torque. Torque is Newton meter. ml square t power minus 2 Newton meter. So this is how we measure certain common quantities. If you take force or thrust, it is normally measured as Newton. Weight, everything is measured as a Newton. What is Newton? ml t power minus 2 per second square, that is t power minus 2. If you have, for example, Young's modulus or bulk modulus, it is pascals. Magnetic flux is in WB. Work or energy is measured in joules. So joules, when you measure work or energy, how do we write it in dimensions? ml square t power minus 2. Or some other thing, ampere per ampere or per ampere meter, we measure as L power minus 1 A. Why it is L power minus 1? Because this is per meter and L is the length. Joules per kilo, JkG. So because it is joules per kilo, L square T power minus 2 is how we write the latent heat for appreciation. What is specific heat? Specific heat is the special heat of that latent quantity at which it will start transmitting it to another body. So thanks for watching this video. We were talking about basics of units and measurement.